Alright, so number one asks us for the graph and the domain and range of this growth function. So what we're going to do first is we're going to find our asymptote. Remember these equations are in the form of a times b to the x minus h plus k, with k being our asymptote. So since this one does not have one indicated, it's 0. So my asymptote is coming across the x-axis as 0. Now my easy point, remember, is going to be h, a plus k, but it's going to have to be opposite sign on the h, same sign on the k. So the easy point here is going to be 0, 1 half plus 0, which is 1 half. Okay, so 0, 1 half. Now I need another point, so I'm going to plug in 1. When I plug in 1, I get y equals 1 half times 3 to the first power, which would be 3 over 2. So the point is 1, 3 over 2. So 1 over 1, 3 over 2 is 1 1/2. So over 1 up 1 1/2. When I connect these, looks this way. And so now I just need domain and range. The domain for this is negative infinity to infinity. It's not restricted in any way. And the range runs from 0 up to positive infinity. Alright, number 2. This one is a little more involved. I do have an h and I do have a k. So here, of course, this is my asymptote at negative 2. Easy point h, so negative 5, and then a plus k, which would be 4. So negative 5 up to 4. Now I just need another point. I'm going to let x be negative 4, and I'm going to plug that in. 6 times 1 half, negative 4 plus 5 minus 2. So I get 6 times 1 half to the first power, which is 3, minus 2 is 1. So this point then is negative 4, 1. 1. This is a decay. And of course you know that it's decay because your b is less than 1. So now I do domain and range. The domain for this one would be negative infinity to infinity because it is not restricted left to right. And the range here from my asymptote, which is negative 2 up to infinity. Number 3, then this is in the form of E, and I have my same easy points and same asymptote. So my asymptote is at 2. My easy point is going to be h, so 0 because it's not there, and then a plus k, which would be 4.5. So 0, 4.5. Now I'm going to let x be 1, and I'm going to plug that into the equation. Of course, I'll need a calculator for this because I don't know what e to the negative 0.5 is without a calculator. So let me just pull this up. So I get I'll have 2.5 times e to the negative 0.5 plus 2. So about 3.5. So that's my y value here, 3.5. So I have the point, this was 2. There we go. So now 3.5 happens about here. And I can connect and hug my asymptote. My domain, of course, again is negative infinity to infinity. And my range is going from 2 up to infinity. Okay? Finally, I have my log graph. Remember, this is where everything is inverted. So I don't have an h here, which means it's going to be 0. It's going to be a vertical asymptote. Now I need to pick two easy points that are going to be easy to work with here. The first one, if I let this be 1, I know that log base 3 of 1 is 0. Then add 2, I get 2, so I get the point 1, 2. Remember, a log is just an exponential on its side. It's the inverse of an exponential. Let's make it be 3. That's another easy one. So I have log base 3 of 3 plus 2, which is 1 plus 2, which of course is 3. So this point is 3, 3. So now when I connect these, I get a graph that looks like, all right, so when I connect these, it's going to hug the asymptote this way. My domain from left to right, the asymptote is at 0, and then it goes off to infinity. And for range, I am negative infinity to infinity. Okay, so for these, we're going to expand these logarithmic equations or expressions, and we're only going to use 4 and 7. So I'm going to do log of 49, I'm going to change to 7 squared, minus log 64, I'm going to change to 4 to the third. I'm going to bring these exponents around to the front so that I have 2 times the log of 7 minus 3 times the log of 4. And I plug in what I know. Log of 7 is about 0.845, so 2 times 0.845, and then minus 3 times 0.602 is the value for log 4 that's given. 2 times 0.845 is 1.69, and 3 times 0.602 would give you 1.806. And so when these two are subtracted, I get 1.69 minus 1.806, negative 0.116. Okay. Again, same thing here, 28. I think I will do 4 times 28. I'll go 4 times 7. So that means I'm going to add the two together. So log of 4 is 0.602 plus 0.845, which will give me 1.447 for that value. Okay. Okay, when you set these up, remember this is, we're using because it's interest is compounded, we're using the formula A times 1 plus R over N to the NT. So quarterly, I start with $2,400, and I do 1 plus, the rate is 3.2, so 0.032 divided by quarterly means 4, raised to the 4 times 7 years. So when you plug this in your calculator, be very careful as you do. 1 plus 0.032 divided by 4 raised to the 28. I get $2,999.90. Okay, so now when I do weekly, my N is going to change to 52. So same formula. The difference here is My n is no longer 4, but rather is 52. So 52 times 7. So I've got the same equation. Let's see. 0.032 divided by 52 to the 52 times 7. I get $3,002.36. And moving on to continuously, that means we're going to use PERT. So it's 2400 E, and then I do 0.032 times 7 times E to the 0.032 times 7 gives me 3,257. So you see they're really close to each other. It's just cents difference. Okay, moving right along. Number 8 deals with depreciation, which means I'm using the simple formula 1 minus r to the t. So I start at $28,750 times, this time I'm going to do subtraction inside. So 1 minus, again it still is a decimal, 0.23 to the 6th power. So 28750 minus 0.23 raised to the 6th power would give me $5,992.14. So that's what it's worth after 6 years. As I simplify these three expressions, first thing here, I'm going to simplify the numbers in front. 24 divided by 4 is 6, and 8 minus 5 would give me 3. This is that property we talked about. If the bases are the same, these cancel and just leave me with 3x. For the last one, I have the cubed root of 16. And I'm going to go ahead and write this as the cubed root of e to the 12th. And here's why. The cubed root of 16, I can simplify as 8 and 2, right? Because the cubed root of 8 is 2. And the cubed root of e to the 12th would be e to the 12th to the 1/3. Okay, because a cubed root is the same thing as a 1/3 exponent. So this ends up with 2 times the cubed root of 2, and then I've got an e here to the 4th. So when we find inverses, remember we switch x and y. Make sure the log is isolated and change the form. A natural log is the same thing as a log base e. So to change the form here, I get e to the x equals y minus 4. Add the 4 to both sides, and you have e to the x plus 4 equals y. Same thing for this one, switch x and y. Change the form here, so I get 4 to the x equals y plus 3. And then, of course, subtract the 3 to get the y by itself, which is then 4 to the x which means that 4 to the x minus 3 equals y. So there's the equation of the inverse. So as I expand this, I want to first split up the fraction. So I have 3x squared minus the 5x cubed. This one's a little bit different. This exponent here is going to come to the front first because it's applied to the whole product here. Whereas, and I am going to just put these in parentheses like this so I can keep the numerator and denominator separate. Okay, I'm going to go ahead and split up these with addition since they are multiplied. So here's still my numerator, and then my denominator is I'm bringing that 3 around front, and I I have the 5x, okay? Now, here the 2 is only going to apply to the x term, this term here. But on this one, it's going to apply to everything. It's going to do, when I split up the 5 and the x, it's going to go to both. So I'm kind of moving my parentheses a little bit here so that the 3 can be applied to both of those. Log base 7 of x. And this is completely expanded. You could leave it just like this. Now this one is easier than it looks. I'm going to change this to exponential form, and the only thing that I can do here to expand is to bring that exponent around front and multiply. Okay. Okay, so as I condense, I want to do the exponents first, bring those around if I have any, and I do, so I have log base 8 of x squared minus log base 8 of 5 minus log base 8 of y to the third. And now I want to work left to right, only 2 at a time, so I'm going to divide here since I'm subtracting, so I have x squared over 5, okay? And now you have to really think about this, because what I'm doing essentially is I'm taking x squared over 5 and I'm dividing it by y to the third, right? Because of the subtraction. So when you divide a fraction by something, what you're really doing, rather than dividing, um, you, you are multiplying by the reciprocal. So I'm going to multiply by 1 over y to the third, and that's going to be the same thing as dividing. So this becomes log base 8 of x squared over 5y to the third. So this one always stumps students because it's subtraction. It looks like you should be dividing a little differently, but that's how we do it, okay? All right, for the next one, I'm going to bring my exponents around. And of course, we're going to work inside these parentheses also. All right, log base 5 of 81 to the 1/4 minus log base 5 of 6 squared minus log base 5 of 4 to the 1/2. Okay, 81 to the 1/4 is 3. 6 squared is 36.
Good morning, Camden High School. Please stand for the Pledge of Allegiance. I pledge allegiance.
Okay, sorry about that, got interrupted by the bell. Okay, so 6 squared is 36. Now 4 to the 1/2 power is 2. Okay, so I'm going to work inside parentheses first. So what I do is divide. So 36 divided by 2, which is 18. So I have log base 5 of 3 minus log base 5 of 18. And of course I'm going to divide here. So log base 5 of 3 over 18, which reduces to log base 5 of 1 over 6. And that is completely condensed at this point, because there is nothing else that I can do to it, no other property that I can apply the way that it sits right now. Okay, so when we solve these equations, what we want to do is we want to make sure, since these are exponential, that the bases are the same. So I can rewrite 16 as 4 to the second power. So 4 to the 2x plus 4 equals 4 to the second power, and then I have the 3x minus 6. So at this point, I can set the exponents equal to each other. So 2x minus 4 is equal to, or 2x plus 4 rather, 2 times 3x minus 6. So now I can just solve the simple linear equation. I have 2x plus 4 equals 6x minus 12. So get the x's together, subtract the 2x, and I have 4 equals, sorry I'm running out of room here. I'm going to bring this up to the top. So 4 equals 4x minus 12. Add the 12 to both sides. 16 equals 4x. Divide by 4, and 4 equals x. Okay, on to the next one. This is a little bit harder. If you think about this as fractions instead of decimals, it'll make it a little easier for you to see what's going on here. So I have 0.25 is the same thing as 1/4, right? And 0.5 is the same thing as 1/2. So if I think about how I can rewrite these with the same base, if you think 1/2, or actually 1/4 is the same thing as 1/2 to the second power. So I'm going to change this 1/4 to 1/2 to the second power, and then the x plus 8 is still there. Okay, so now the bases are exactly the same. So I can set the exponents equal. I can have 2 times x plus 8 equal to x squared plus 1. So again, this is 2x plus 16 equals x squared plus 1. And I think you know where we're going with this one. We have a quadratic. We're going to make it equal 0. So move the 2x and move the 16. Oh no. Minus 2x minus 16. I'm going to just do it all at one time. And so I end up with 0 equals x squared minus 2x minus 15. This is a factor and solve, so you don't have to use the quadratic formula. X minus 5, x plus 3. If I set both of those to 0, then I have x equals 5. Someone's trying to catch up with me. And x equals negative 3 are my two solutions here. Alright, so now to solve the log, what I want to do is condense the left side first. So I'm going to do the exponents first. So I've got log base 4 of x squared plus log base 4 of 4x equals 4. Let's continue to condense, and so I have log base 4. X squared times 4x would be 4x to the third. Now I'm down to one log, so I can change forms. 4 to the fourth power equals 4x to the third power. Need to get x by itself, so I'm going to divide by 4. So 4 to the third equals x to the third, and of course, since the exponents are the same, x must equal 4. Okay, for the next one, actually the last one here. Okay, so clearly I forgot to hit record. I do apologize. But I've got the solution here. We changed the form, made it equal 0, factored and solved here for this very last one. Okay. Okay, let's go.
Hey guys,